Say you have an idea that will cost $1,000 to go to market and will return $3,000 to you later. It looks like a sure winner, right? Well, if you invest $1,000 today and get the $3,000 in a year, then sure, sounds good. But what if you invest $1,000 today and get $3,000 returned to you in 20 years? The profit is technically the same in both examples, but you see the problem, right? Who wants to wait 20 years? There's definitely a cost to the amount of time you need to wait. And who knows what will happen in the meantime? We have a solution, which is to calibrate the risk and time into the analysis by employing a concept called net present value. Say you have a project that will cost $20,000 today and is forecasted to produce $10,000 of inflows for 3 years. How much money is this project expected to earn you? Well, it looks like there's a simple solution. Inflows of $30,000 minus an investment of $20,000 equals a projected profit of $10,000. But what if your investors expect a rate of return of 10% a year on their $20,000 they provided to you to fund the project? In that sense, the future flows of $10,000 per year need to account for not just the initial $20,000 investment, but also the 10% per year additional return the investors expect. To be able to do this, you must first find the present value of each of the future cash flows. Then it is appropriate to add them up, since now the cash flows will be all represented in an apples-to-apples format. To find the present value of a cash flow, you need to divide by 1 plus the 10% return for each year. Let's do it with this example. Our initial investment is a $20,000 outflow. Since that occurs in the very near term, it does not need to be adjusted. Our first cash flow is a $10,000 inflow, which occurs roughly 1 year from today. To find its present value, just divide 10,000 by 1 plus 10%, or 1.1. So the computation is 10,000 divided by 1.1, which gives us $9,091. This is what is called the present value of 10,000 discounted 1 year at 10%. On to the second year. The year 2 cash flow is another $10,000 inflow. So we divide 10,000 by 1.1, then again by 1.1 since it occurs 2 years out. The result is $8,264, which would be considered the present value of the second 10,000. On to the third year. The year 3 cash flow is a final $10,000 inflow. This one occurs 3 years from now, so we divide it by 1.1 3 times and end up with a present value of $75.13. So where do we stand? We have an initial outflow of $20,000 and present values of the 3 future inflows sum to $24,868. So the true value created from the project is $24,868 minus $20,000 or $48,68. This is called the project's net present value. Notice that the project's profit is still $10,000, but the economic value that is expected to be created is estimated to be $48.68 in today's money. The net present value criteria is well known in large and medium-sized organizations, less so in small companies. But the greater the return expected from investors, the more that this should be embedded into the analysis of an idea's attractiveness. The net present value, among other metrics, involve all the relevant cash flows that the project is expected to throw off. The interpretation is that when all the accounting and economic costs of operating and financing the project are considered, if the net present value is positive, the project is expected to create value. If the net present value is negative, then the project does not pay for itself nor the funding sources, so you need to think carefully about proceeding.